So correlation, okay, is what we use, okay, to quantitatively measure the so-called linear association, okay. Yeah, and when you do like a correlation, okay, never forget to try to plot the data sets, okay, because yeah, I mean, you have to see it, okay, before you can tell like whether it's linear or not, okay. Now, linear relationships are important because straight lines is simple. Yeah, that's pretty straightforward, right? The correlation R measures the direction and the strength, okay. Now let's talk about R. So it's always between -1 and 1, okay. We'll talk about this later, okay. And I explain to you, okay, what it really means, okay.
Okay.
And then R larger than 0 indicates a positive association. And R smaller than 0 indicates a negative correlation, okay? And then value of R near 0 indicates a very weak linear relationship. And the strength, okay, as R moves away from 0 and towards -1 to 1, okay? And finally, okay, the extreme values, okay, -1 or 1 only, a perfect linear relationship, okay?
This is, I've done this before. I've done this before.
You've done this before?
Yeah.
Cool. Nice.
This was probably like, I feel like pre-calc.
Really? I don't think so.
I
Why? I mean, how? Why? Okay. Anyway, so this is like how you calculate the so-called correlation R, okay?
Okay.
Now, if you were to say this is n-1 over n-1 is like you calculate the average, okay? Now, this is how I view the correlation, okay? See here, we have actually we have this is we can write this term, okay, as zx, can we? That's like the z value for the x data set, and this is the zy, right? This is the zy value, okay. And then you want to you multiply the two any possible pairs of x and y z values, okay, and then you add them up, you do the so-called like a no, my bad, okay, it's not any pair, okay, it's like for each individual, okay, got it, for each individual or any point, okay, you have the z x values and zy values, right? Now you can like do and then you multiply them together. You do the average, okay, of the sum, okay. The average of the product, okay. Now, let me see how I can explain this to you, okay, more clearly, okay. Why in R value a lot closer to 1 or -1, okay, is indicates, okay, a stronger linear correlation, okay.
Wait, so z value, if instead of using the standard deviation value, you use a z value, then that means you're standardizing the data.
Yeah, I mean, look at it, okay. Isn't this the standardization of x?
Oh yeah, it is.
Xi minus x mean. And
so that's the z value. That entire
that's
term.
the z value, right?
And I thought you were only pointing to the denominator.
No. The entire thing, okay. Okay.
Got you. Yeah.
Okay, forgive me, okay. It's like the entire term, okay, and this is the entire term, okay. Now, let me jump a little bit ahead, okay, to explain why an R value closer to 1 indicates a stronger linear correlation, okay. Hold on, let me see. I have to go to the book again. And R value. Yeah. See, we have X values and Y values, and then they're both standardized, okay, to Z values, right?
Mm-hmm.
Now, when you do Z values, okay, if the linear correlation is pretty strong, then you basically have points or Z values distributed thus, right?
Mm-hmm.
So here, and this is like the ZX, okay, that's the Z values of the X data set. And this is the Z value of the Y data set, okay?
Yeah.
Now, we have quadrants, quadrant 1, 2, 3, and 4, right?
Mm-hmm.
Yeah, it's like this. When you have like a data points mostly in quadrant 1 and 3, aren't the Z values, don't we have Z values, okay, for each data point with like the same sign? Like in quadrant 1, both ZX values and ZY values, okay, are positive, right?
Yes.
And in quadrant 3, they're both negative, right?
Yeah.
And if you were to multiply them together, you get positive values, right?
Yeah.
I mean, in both quadrants. Now, if you were to add them up, okay, you get a large sum, don't you?
Yeah.
Okay. I mean, when you get a larger sum, you get a large average value. So you get a large R value, right? That's when your R value is close to 1. Got it? See here? So, both positive, right?
Yeah.
And then both negative, okay?
Mm-hmm.
As I said, okay, then you have a large sum, and then you get a large R value. Got it?
Large sum when you add them together. When you
No,
add
no,
them,
no,
when
large
you add
sum,
their product.
large
When you add their
sum, okay?
product.
It's like this, okay? ZX, right? Times ZY. Got it?
Yeah. So they have you're the sum
And
of their product.
yeah. The sum of the products, okay?
Yeah.
And so R is like equal to the sum divided by n minus 1, right?
Yeah.
So it gets close to 1, right?
Mm-hmm.
Would you agree?
Yeah.
Nice.
Wait. N-1 multiplied by that sum.
Well, n minus 1 is a constant. Come on. N is like the number of data points.
Yeah, number of data points. Yeah.
So that does not affect, okay, it's trend, okay, whether it's large or small, right?
Mm-hmm.
The only thing you need to care about is like how whether you have a large sum or not, okay? In this case, the sum is pretty large. Would you agree?
Yeah.
Okay. Now, if the points are scattered in quadrant 2 and 4,
Both.
would you?
Yeah. Okay. So
Yeah.
one positive and one negative.
Don't you get a very negative sum? Right?
Yeah.
Because you have almost all negative products, right?
Yes. Yeah. It's true.
So for this one, it's just like very negative, okay?
Yeah.
Very negative sum. So R close to -1. Got it? All right. Now, what if we have a distribution like this? Can I erase all these?
Yeah. You're good. Yeah.
Nice. Okay, if I were to do this, okay, it's like we have something like this. Now, in this case, we have a sum very close to 0. Would you agree? It's like you have positive ones, negative ones, and then they cancel out, mostly.
Yeah.
Largely cancel out each other, right?
Mm-hmm.
Right. So in this case, very small sum, okay?
Just to be clear, every time you say sum, you mean the sum of the products.
Yeah, our products.
Okay.
Yes.
Okay, gotcha.
The product, okay, or z values, okay?
Yeah.
Yeah. So, I mean, conceptually, I want you to really have a better understanding of like why an R value closer to 1 or -1 indicates a strong linear correlation, relationship, and an R value close to 0 indicates a weak correlation. Okay, got it?
Yeah.
Cool. And you can do other things as well. Okay, for example, you can do, I don't know, like something like this. Okay. It's like pretty, curved, okay? And then the sum of the products, or the value products, okay, also largely cancel out, right?
Yeah.
Right. So in that case, you also get a small R value, or an R value close to 1. That makes sense?
Yeah,
So,
well, I'm trying to think about it. Like the product, negative. Yeah, that's positive, and that's going to be negative. Okay, that cancels out. Yeah.
See, that's how I understand. How I make sense of R values. Okay.